Okay, so this is problem 1.5.81, and they ask us to solve the following equation using an appropriate substitution, and they want us to check our answers. And then they're giving us the solution set is, they want us to type the exact answers using radicals as needed. Okay. All right, so if we're going to use a substitution, they're talking about using U substitutions in this problem. And so what we want to do is we want to notice where is the quadratic form. There's a quadratic on the inside of these parentheses here, but that's the overall quadratic that I'm looking at is I have something squared here, and then plus 4 times that same something to the first power, and then minus a constant. So the quadratic form is actually, you can notice it here if I say let's let u equal x squared minus 6. And then this equation reduces down to u squared plus 4u minus 5 equal to 0. Okay, so, excuse me. So, by allowing u to equal x squared minus 6, then everywhere there's an x squared minus 6, I would be plugging in a u, and then I would just be doing to that whatever's being done to this x squared minus 6. So you see this right here is being squared, so then I square my u, and this is being taken times 4, so I have times 4. So that's where I'm getting that. Okay, so what we want to do now is we want to solve this resulting equation, and then once we've solved that, we want to actually back substitute what we find for u into this equation because we're actually trying to solve for x. Okay, so it looks to me like this factors. Let's try it. If it doesn't factor, we can stick it into the quadratic formula. But if I use a 5 and a 1 and a plus and a minus, outside and inside would give me a positive 4, and the last would give me a negative 5. So it does factor. So we would set u minus 1 to 0 and u plus 5 to 0. And then we're solving here. So add the 1, we get u equals 1, and subtract the 5, and we get u equals negative 5. Okay, so now what we're going to do is we're actually going to back substitute. Where we have a u, we're going to plug in x squared minus 6, and we're going to solve that. Okay, so I have x squared minus 6 equals 1, and x squared minus 6 equals negative 5. So I have two different things to solve. Okay, so here when I add the 6, I have x squared equals 7, and then here when I add 6, I have x squared equals 1. Okay, and we're solving for x, so we need to take the square root of both sides. This is going to be plus or minus the square root of 7, and then this is going to be plus or minus, plus or minus 1. Square root of 1 is just 1. Okay, so you have actually 4 answers there. Plus or minus square root of 7 and plus or minus square root of 1. I keep saying that. Plus or minus 1. The square root of 1 is just 1. Simplifies to be 1. Okay, I'm realizing the person that, so this problem is done. This particular problem is done. But the person that emailed me asked me about simplifying the square root of 8. I don't see a square root of 8 in this problem, so you may have made a mistake there. But let me just address that question anyways. If you want to simplify the square root of 8, what you're doing is you're saying, can I write this in the form of something squared? So I would say, yeah, this is actually, I can write this as the square root of 8 is the same thing as the square root of 4 times 2. And the square root of 4 times 2, this is a perfect square. So you can think of that as the square root of 2 squared times 2. Whenever you get, there's an assumed 2 here when we're talking about square roots. Whenever you get your index and your exponent to match, this piece can come out. So this becomes 2 times the square root of 2. And that was a question that was just asked. I don't know, it doesn't apply to this problem, but that's how you would simplify the square root of 8. And then I guess I should mention over here the square root of 1. The reason that I got a 1 is because the square root of 1 is the same thing as 1 squared, and then the index and the exponent match, and you can just bring it out as a 1. Okay, so simplifying square roots is prerequisite knowledge for this course. So if you don't remember it, you should go back into an intermediate algebra text and take a look at it, because it's definitely something you'll need to know how to do.